Well, in this video, I will show you how to multiply one matrix times another matrix. Now, the first thing you want to do, so for number 8, I want to multiply matrix A times matrix B. And notice that the order matters. When we get to number 9 and do matrix B times matrix A, that'll be a completely different thing. These are not the same. So, what you do is you analyze the dimensions. Matrix A is the first matrix, and the dimensions are 2 by 3. Alright, matrix A is a 2 by 3 matrix. Alright, 2 rows, 3 columns. The second matrix is a 3 by 2 matrix. Alright, it's a 3 by 2. 3 rows, 2 columns. For the matrix multiplication to be possible, the inner dimensions must be the same. So these dimensions have to be equal. They are, so this is defined. It is possible. Now, to know the dimensions of the product, your final answer, look at the outer dimensions. So the outer dimensions are 2 by 3. So matrix AB is going to be a 2 by 3 matrix. I'm sorry, the outer dimensions are 2 and 2. So the outer dimensions tell you that the product is a 2 by 2 matrix. Now, that is very important because when I show my work, I need to know the dimensions of my final answer so that I can set up an empty matrix to work in. So since the product is a 2 by 2 matrix, right now I'm going to set up a 2 by 2 empty matrix like this. Now, to find each of the 4 entries, I'm going to be multiplying rows and columns. And the way it works is you multiply rows from the first matrix times columns of the second matrix. So all my rows will come from here and my columns will come from here. So if I want to find the entry in row 1, column 1, then I am going to multiply row 1 by column 1. And here's how I do it. So row 1 is 205. Even though it's a row, I'm going to write it vertically for easy calculation. 205. So this is my row. And now that's supposed to be multiplied by this column, which is 6, 10, negative 2. Okay, when I multiply these together, I'm going to get 12 and 0 and negative 10. For the final answer, I need to add these up. So 12 and negative 10, that's 2. So this entry is going to be 2. Now, if I want to find the entry that belongs in the first row, second column, I am going to multiply the first row times the second column. So the first row is this 205 again. And I'm going to multiply that times the second column, which is negative 3, 0, and 1. If I multiply these, I'm going to get negative 6, 0, and 5. If I add these up, I get negative 1. So this is going to be the entry in the first row, second column. Now, if I want to find the entry that belongs in the second row, first column, I need to multiply the second row times the first column. Okay, so second row, first column. So that's negative 1, 3, 2. So negative 1, 3, 2. And that's times 6, 10, negative 2. So 6, 10, negative 2. If I multiply these together, I'm going to get negative 6, 30, and negative 4. I need to add these up. Negative 6 and negative 4 make negative 10. 30 minus 10 is 20. So this entry will be 20. So one more time. If I want to find the entry that is in the second row and second column, I need to multiply the second row times the second column. So the second row is negative 1, 3, 2. And the second column is the negative 3, 0, 1. So if I multiply these together, I'm going to get positive 3, 0, and 2. If I add these up, I'm going to get 5. So this will be the entry in the second row, second column. So if you just look at the numbers that I have boxed, they show you the final answer. So the final answer, the product will be 2, negative 1, 20, and 5. So that's how you multiply a matrix times another matrix. Let's look at another example. Same matrices, but this time we'll do matrix B times matrix A. Okay, so we have to be very careful because the way the matrices are written, they're in the reverse order from what we're looking for. In other words, matrix B has to now be considered the first matrix. Okay, so this is the one that is first. And matrix A is second now. So this is the one that is second. So when we start multiplying rows by columns, the rows always come from the first matrix. So this time around, the rows will come from matrix B. The columns always come from the second matrix. So the columns will come from matrix A. So let's analyze the dimensions of these two matrices and see if it's even defined, if the product is even defined. Matrix B has dimensions 3 by 2. Matrix A has dimensions 2 by 3. For this product to be possible, the inner dimensions have to be the same. Notice that the inner dimensions are both 2, so this product is possible. It is defined. The outer dimensions will tell us the dimensions of the product, the dimensions of the final answer. So the final answer will be a 3 by 3 matrix. That's important because right now I need to set up a big empty 3 by 3 matrix. So that's what I'm doing now. Okay, I need a 3 by 3 matrix. This is going to be pretty big. Okay, so I'm setting up to have my 3 rows and 3 columns. Alright, let's get to work. Okay, this time, instead of doing each element one by one, I'm going to write down all of my rows first, and then I'll do all of my columns. That'll speed up the process a little bit. So remember, my rows are going to all come from matrix B. So if I want to find the entries that are in the first row, they will all involve multiplication by the first row. So that's why all of these entries will have 6, -3 as a factor. So I'll just put 6, -3 for every entry in this row. Okay, now look at the second row. Since the second row is 10, 0, then I'm going to put 10, 0 as a factor in the second row. Alright, so you see how it works? The first row gets the first row. The second row gets the second row. And the third row, of course, gets the third row. Alright, the third row goes in the third row. So that's why I'm going to put -2, 1 all the way across. Alright, so it's just a little quicker if you do this all at once. Repeat, repeat, repeat. Okay, now let's shift gears and talk about the columns. Okay, all of the columns will come from matrix A over here. Alright, all of the columns will come from matrix A. And the first column will go in the first column. So I'm going to put 2, -1 all the way down the first column. The second column goes in the second column. So I'm going to put 0, 3 all the way down the second column. And guess what? The third column belongs in the third column.
Wow.
Right? Did I just blow your mind, kid? So I'm going to put 5, 2 all the way down the third column. I bet you thought high school math was hard.
I did.
But it turns out, oh, the third column goes in the third column. No one would ever guess that. How can I possibly remember?
I know, right?
Alright, so it's a little bit quicker if you set up all of the rows and all of the columns ahead of time. Alright, it's all about efficiency. So now I'm just going to multiply these together to get the answer. So if I multiply here, I get 12 and 3. Add them up, and that's 15. Multiplying here, I get 0 and -9. Add them up, that's -9. Multiplying here, I get 30 and -6. Add them up, that's 24. Multiplying here, I get 20 and 0. Add them up, that's 20. Multiplying here, I get 0 and 0. Add them up, and that's 0. Multiplying here, I get 50 and 0. Add them up, that's 50. Multiplying here, I get negative 4 and negative 1. Add them up, that's negative 5. Multiplying here, I get 0 and 3. Add them up, that's 3. Multiplying here, I get negative 10 and 2. Add them up, that's negative 8. So each of these numbers that I have boxed represent the final answer. So my final answer will be the matrix 15, negative 9, 24, 20, 0, 50, negative 5, 3, negative 8. So this is the final answer. So notice, one more time, we multiplied a times b, and this is the answer that we got. Then we multiplied b times a, and this is the answer we got. Not only are the numbers different, but the dimensions aren't even the same. So in other words, matrix multiplication is not commutative. When you were dealing with real numbers, 3 times 5, 5 times 3, they're both going to give you 15. Not so with matrix multiplication. Take a look at number 10. How do we square a matrix? Do we just square each of the individual numbers? Will this be 9, 1, 0, and 25? Oh no! Oh no! C squared means C times C. So that's what you must think. Matrix C times matrix C. We have to do matrix multiplication. First, let's analyze the dimensions. The dimensions of matrix C are 2 by 2. So I am going to be multiplying a 2 by 2 matrix times a 2 by 2 matrix. Is this even possible? Well, the matrix multiplication will be possible only if the inner dimensions are the same. Since the inner dimensions are both 2, this is possible. So I'm going to be doing, I'm going to need to know the dimensions of the final answer. I can find the dimensions of the final answer by looking at the outer dimensions. The outer dimensions are 2 and 2. So that means my final answer, the product, will be a 2 by 2 matrix. That's important because that tells me that to do my work, I'm going to need to set up an empty 2 by 2 matrix. And here it is. Here's my empty 2 by 2 matrix. This should be plenty of room for what needs to happen. Okay, so look, here's matrix C. And just for fun, I think I'll write another matrix C right next to it. So here's another matrix C. 3, 0, negative 1, 5. Alright, this is just so I can separate it out into rows, which will come from matrix C, and columns, which will also come from matrix C. So, I need to multiply these rows by these columns. And I think I'll write down all my rows first, and then I will write down all my columns. So every entry in row 1 will involve multiplying by row 1. So row 1 will appear in row 1. So that's why I'm going to have a 3, negative 1 in both of these entries. Okay, now row 2 will appear in row 2. So 0, 5 will appear in row 2. Alright, in all entries of row 2. So that's it for the rows. Alright, now let's talk columns. Okay, column 1 will appear in column 1. So that's why 3, 0 will appear all the way down, column 1. Let's move on to column 2. Column 2 will appear in column 2. So I will have negative 1, 5 all the way down column 2. Now I will multiply and add. If I multiply these together, I'm going to get 9 and 0. Add them up, that's 9. Multiply these together, I get negative 3 and negative 5. Add them up, that's negative 8. Multiply these, I get 0 and 0. Add them up, you guessed it, 0. Multiply these, I get, 0 and 25. Add them up, and it's 25. So these numbers that I have boxed represent the final product. So matrix C squared is the matrix 9, negative 8, 0, and 25. This is the final answer.